Hello everyone. Today I will show you my implementation of the gravity gloves from Half-Life Alyx. The technique is straightforward for the most part, but you need to know some calculus, trigonometry and linear algebra. Oh, I forgot, you also need physics. As you can see, raycasting is first used from both hands to check what they are being pointed at. Then, if the grip button is pressed, we store the transform of the object in a buffer. The following code is to span a particle system. Once the target item has been stored, we need to wait for the player to flick the hand. This is done with a dot product between the camera forward vector and the controller's velocity. If the dot product is negative and its absolute value is greater than the sensitivity of our choice, begin the attraction. Now listen carefully. This is where it gets complicated. Imagine the item and the player's hand in a 2D plane. We need to calculate the parameters of a parabola intersecting its axis at the item's position, and with its vertex at the player's hand. This allows us to find the starting angle for the motion. Simply take the derivative of the parabola at the item's position. You get the slope of the parabola in that point. The arctangent will give you the corresponding angle. Now we calculate the velocity module. This is where physics comes around. Take the formulas of projectile motion and calculate the velocity. Now it's time for the direction vector. Subtract the player's hand position from the item position. Set the y component to 0, and normalize it. What you get is the projection of the force unit vector on the XZ plane. Rotating it into the correct position is going to be hard. First you calculate the rotation axis with a cross product between the projection vector and the vertical unit vector. Then, you use quaternion functions to rotate the projection vector around that axis. The angle value is the one you calculated before with the arctangent of the derivative. Beware though. You calculated it in radians, now it must be converted into Euler degrees. Oh, and don't forget to also add a second velocity vector to oppose gravity in that instant. It's done. The next step is to apply the calculated velocity to the item. Thank you for watching. I have prepared a cake for you. All voice lines have been generated at 15.0.